Hello everyone, welcome back to my channel. Today I'm going to doing this what is hot right now is a Cybertruck, which is from the Tesla company, which is doesn't really announce what is the performance of the aerodynamic of this vehicle. So in this occasion I would like to create the simulation, which is I'm using the CFD Autodesk CFD 2019, and then see what's the result of the simulation. As you can see here, if I animate this the velocity profile, and then we were going to find out what is the performance of this vehicle, and also we would like to calculate the coefficient of drag. Okay, get ready and then let's get started. Okay, this vehicle was downloaded in the GrabCAD, and I will put the credits the owner who created this. I think it's awesome, but I made a little bit of changes. Like here, as the original, they have a trunk. So if I like this trunk, okay, and also I'm create the profile for the area here, but this trunk, actually the original one is they don't have any trunk inside there, so I put the boundary fill inside. So but I'm not going to show you how to create this kind of modification, and I'm going to show you how I perform the simulation for the CFD. Okay, as you can see here, after all the 3D model is completed, and then you can change to here. Prior that, I would like to stop this one, and then I would like to close first. Okay, from here you go to the simulation, and then because I already installed Autodesk CFD inside my machine, so if you see here, there is a simplify surface, and then there's a tools over here. So when you install the CFD, Autodesk CFD in your machine along with the Fusion, so they will show up this icon here, and then I just click this one, simulate in CFD. They will automatically open the Autodesk CFD, and then maybe I would like to save to the proper okay, select folder, launch, and then they will automatically open the CFD software for you. Okay, this is it. Okay, it's finished, and then they have a tools which is a geometry tools, and from these geometry tools we can select whether the object or the model can be simplified like this. Maybe there's a small edges, so I would like to merge, click merge there. Okay, and then what about the small object? So basically this tool is for the eliminating all the unnecessary object here for the edge and also the surface which is very small. They will merge together, so it simplify the simulation. So from here I would like to use 0.5. okay, and then this for the edge, and I click remove. Okay, I think the model is already good enough. And then last one is we built the external volume, which is like a wind tunnel, which is a virtual. So I need to create, we just drag it, click and drag, and then usually I will use this maybe twice, more than twice of the length of the object, and then also this one is twice height. And for the side, okay, probably is one of the width of the object. Okay, I think it's good enough. And then click create to create the external volume. So in the CFD they have two type of the simulation, which is internal and external. If this one in this case is the external analysis. Okay, after that you can close the dialog box, and as you can see here, they will create the CFD created volume, which is basically just the simulation model is the model which I import, and CFD create volume is basically they just create the surround air, or maybe whatever it is. It will be a solid or a fluid or solid object, which is just the algorithm is subtract with this box here with the inside here. Okay, and then we're going to create the materials. Okay, I will create this one as a volume, so I edit the material. So this one I would like to use the fluid and the air. Okay, apply. And for the simulation here I will use solid, and I think it's a steel is okay. Okay, and then the next one is mesh. Okay, if you just can edit the mesh and then click the automatic size to calculate the average of mesh size in this particular case. So basically they just create the dot which is indicate the mesh size, and I would like to use the surface refinement and wall layer. Maybe I will use 5 wall layer, and then I will use the layer gradation 1.25, and the layer factor is 0.5. Okay, and then I think that's all the setting. Okay, and then just click refine. So the software will refine all our setting which is already applied, and then they apply to the surface over there. So basically this wall layer, they create a layer wall, and this for calculating the boundary layer, which is to calculate more accurately to the turbulence phenomenon near the wall. Okay, after finish, and then we just can apply the surface, the mesh, and I continue with the boundary condition. So this is basically just the input, so I will use the velocity, and then I will use steady state and normal, and then the value will be 104, which is 65 miles per hour, around that 65 miles per hour. And then here is the here is an inlet, and here is the outlet. So the outlet will be the zero pressure gauge. Okay, and then I will use this wall using the slip wall or symmetry. Okay, from top as well. So you slip. Okay, and then the last one is here, also using the slip symmetry. Okay, so basically 1, 2, oh, this one should be okay. Yeah, okay. So 1, 2 in the top and the left side. Okay, at the ground area I don't put any definition, so they will consider as a normal wall, and mesh sizing is already, and then I would like to create the generate mesh. Okay, now okay, after we create the mesh, and then we can continue to the solve here. Okay, so in this solve I would like to create the solution control, and yeah, this is for the automatic convergence, so I'll leave it at default. And then I would like to simulate all the turbulence activity here, and then I don't want to simulate the temperature, but pressure and velocity, shear stress, heat flux I don't need it, wall film I also don't need it. Okay, and maybe a pressure coefficient, and this is the incompressible, and there's no heat transfer over there. So the turbulent, I would like to choose the SST K omega. Okay, to simulate the turbulence. Okay, there's no scalar, and also there's no adaptive to shorten up the result of this mesh. Okay, and then after that we use the iteration, how many iterations that I would like to run this simulation. I will use 300s, and then start from 0. Okay, and then before that, okay, I think I just can click solve to this particular case. Okay, solve, and then they will automatically create the solve this simulation for us. Okay, as you can see here, this is the plot table, which is indicate the convergence plot during the every iteration, and I'm going to create a planes here. Add a plane, and edit, and this is the direction of the plane, so I will use the Z direction. Okay, so starting now to the simulation over there. Okay, so this is the basically is a the velocity. Okay, velocity profile. Okay, and I will turn off the still over here. Okay, they now iterating, and then this is the iteration number 4. So they will iterate through until they will finish, which is conversion, or which is they will reach the 300 that we already set. So if the result is converts before the 300, they will stop automatically according to our setting. But if not, they will continue iterate until 300. If that's so, we will like to see what is the result of this simulation, which is already converts or not. Okay, see you in the next one. Okay, now the simulation has stopped, and then let's see what is the result here. So both of the three here is already converts, but the velocity in the z direction is not yet converted, it's still up and down. But let's see the result from here. Okay, as you can see here, here is the velocity profile, which is have the high speed around at the tip of the top of the car. Okay, and then this is the, if you can see here, the plane, I show up the meshes. So this is the wall boundary. This is all around the meshes, and then with this boundary we can calculate the boundary turbulence in the particular surface or for the shape. Okay, and then let's create a trace. Okay, create a trace. So I need a rectangular trace. Okay, I will add from here and then from here. Okay, so this is the trace, and let me edit the shape here. So this is the velocity trace. I will change to lines. Okay, and I turn on the, let me see, oh yeah, okay, that one. So this one, basically, if I use the pressure here, okay, so this is, they come up into the pressure in the front of the frontal area, which is directly hit with the wind, and also at the wheels here, in the front wheels. Okay, for the trace you can simulate or animate the result. Okay, so we can see what's the profile, velocity along with this shape. Okay, let me turn off the axis here. Okay, and then we would like to see as well the let me turn off first. So usually when you create a simulation like this, you want to know what is the drag force to calculate the drag coefficient of this particular car. Okay, so this one I will click the wall calculator. I will select all, but I will deselect this surface here, surface here, surface here, and then surface over there, and also at the bottom, and as well as at the back. So basically I just want to calculate the force which is acting only on the car. Okay, and I click the force and I click the Newton. Just calculate. So they will calculate all the boundary area which is in the below here. You can see the particular total force according to the axis here. So it's a x-axis. X-axis is the force 1012.82 Newton, and for the y is 21, but yeah, 21 Newton. And then this one is for the z. So is z should be, because it's the symmetric, right? The z should be not as much as this one, but if we see here, because the z, we see the velocity of the z is still not converged yet. If you like, so maybe you can add another iteration to put this, the z axis is converged, but from this x here is already converged. So this value I will copy to my calculation to the drag force, drag coefficient here. So 1012.82. Okay, so this is the result of the drag force. Is a bit higher than the predicted, because some people have a discussion in the web, in the internet, which is this car can perform at least 0.4 of the drag force. They use another software, or maybe I think because of the complexity of this detail here. So in this particular car here, as you can see, there is a lot of detail that I not simplified. It's like this bumper is fender, and also the shape of the rotating this wheel. So they also influence to the drag force here, and also the front shape here. So it's many sharp edges, and as well as here, I think because of that, the detail of the shape of this car is influence the drag coefficient is a bit higher than the predicted. And also the wheel rim here, they actually influence the drag force here. So as you can see here, the flow is flowing under the hood, and as well as at the bumper here. Okay, they're flowing in the sideways here. Okay, at the back, if you see the animation here. Okay, yeah, I think it's conclude all this simulation. And if you have any question or any do you have any thought or comments, please write down in the comments below, and then we can discuss about this case. Okay, thank you for watching, and then keep following my video. I will create updated video to the related of the engineering topic. Okay, bye bye.